From the invisible world beneath our eyes to the technology that drives our modern age, nanotechnology stands at the frontier of human innovation. It's a science that manipulates matter at the atomic and molecular scale, creating materials and devices smaller than 1/10,000th of a human hair. In this video, we'll explore how it all began, where it stands today, and what advantages and risks come with it. Our story begins in 1959, when Nobel Prize-winning physicist Richard Feynman delivered a lecture titled "There's Plenty of Room at the Bottom." In it, he proposed a bold idea: what if we could arrange atoms one by one to build entirely new materials and machines? At the time, it sounded like science fiction. In 1974, Japanese scientist Norio Taniguchi coined the term nanotechnology to describe manufacturing at the nanometer level, 1/1000th of a meter. But it wasn't until 1981, with the invention of the scanning tunneling microscope at IBM, that scientists could finally see and manipulate individual atoms. The late 1980s and 1990s marked the dawn of true nanoscience. In 1985, researchers discovered fullerenes, carbon molecules shaped like tiny soccer balls known as buckyballs. Then, in 1991, Sumio Ajima discovered carbon nanotube cylindrical structures hundreds of times stronger than steel, yet incredibly light and conductive. Scientists also created quantum dots, nanocrystals that emit vivid colors when excited by light, paving the way for advanced displays, imaging, and sensors. By the early 2000s, nanotechnology had moved from theory to practice. Governments worldwide launched major programs, such as the U.S. National Nanotechnology Initiative in 2000, funding billions in research. Nanotech began shaping everyday life since screens that use titanium dioxide nanoparticles to block UV light without leaving a white residue, self-cleaning windows coated with nanothin films, and water-repellent fabrics. In medicine, nanoparticles were designed to carry drugs directly to disease cells, targeting cancer while minimizing harm to healthy tissue. The 2010s brought new breakthroughs. Graphene, a single atom-thick layer of carbon discovered in 2004, revolutionized materials science. It's 200 times stronger than steel, transparent, and conducts electricity better than copper. Nanotechnology entered renewable energy, enhancing solar cells, batteries, and hydrogen fuel cells. In electronics, nanotransistors allowed chips to become faster and more efficient, fueling the rise of artificial intelligence and smartphones. Today, nanotechnology is part of nearly every scientific field. In healthcare, lipid nanoparticles made global headlines during the COVID-19 pandemic, delivering mRNA safely into our cells for the first time in human history. Researchers are building nanorobots that can navigate the bloodstream to remove clots, repair tissues, or deliver drugs precisely where needed. In computing, neuromorphic nanomaterials are being used to mimic brain-like learning systems. And in environmental science, green nanotechnology is tackling pollution, clean water generation, and carbon capture. Nanotechnology offers immense benefits. Miniaturization devices become smaller, faster, and more efficient. Medical precision, early disease detection, targeted therapies, and faster healing. Environmental solutions, cleaner energy, efficient filters, and waste reduction. Stronger materials, lighter aircraft, flexible electronics, and durable coatings. However, every technology has two sides. Nanoparticles can be toxic if inhaled or absorbed, as they interact differently with human cells. There are also concerns over privacy, job displacement, and ethical misuse, especially if nanosurveillance or military nanotech becomes uncontrolled. The lack of global regulation and safety standards remains a challenge. In the coming decades, scientists envision molecular assemblers, devices capable of constructing materials atom by atom. Imagine repairing organs, producing food, or cleaning pollution at the molecular level. Nanotechnology could merge with AI, biotechnology, and quantum computing to create an entirely new technological era. Nanotechnology began as a dream of manipulating atoms. Today it's the engine driving medicine, energy, and electronics, and tomorrow it may reshape life itself. Thank you for joining us on this journey through the world of nanotechnology. If you enjoyed this exploration, like, share, And subscribe to Tech-Abyssinica, where we bring technology closer to understanding.